I think the ability to use artificial intelligence to find new scientific insights is incredibly exciting. Because if we manage to do that, if we could accelerate the pace of science so that you get 100 years of expected scientific progress, but in the next 10, I think that's the best bet we have of addressing the complexity question. We can get continued progress if we can use science to address the complexity that progress creates. So this is true for finding new drugs, finding new materials, finding new mathematical physical insights. You can essentially imagine a world in which science is automated, and there's constantly a set of large data centers with, I think, a nation of scientists was what Dario Amodei wrote in one of his essays, that work on these problems. And ultimately, there are two perspectives here. One is, let's build a better scientist, which is an interesting perspective, because then if you think about what a scientist is, it's somebody who is conducting science within the framework of a theory, and that's valuable. But the theory sets the ramifications and the conceptual frameworks for what that scientist can do. Now, there are two kinds of discovery processes in the world. One is the scientific one, where you start with a theory and you sort of build that out with hypotheses and experiments and all of those kinds of things. That's brought us a lot of value. What we possibly now have the chance to do is to build a theoretical science. So a theoretical science already exists. Nature invented it. It's called evolution. Evolution doesn't care about what physics theory you have. Evolution will use what's there in order to build advantage. That's why we find now, many years later, that there are quantum phenomena that's been utilized by evolution in biological systems. So, for example, the ability of birds to navigate, or the ability of plants to turn solar power into chlorophyll, etc. All of those actually have, in quantum biology, been detected to have certain quantum effects that evolution just used because it was there. Evolution is completely atheoretical. It just finds things that work, mechanisms that give capabilities that allow us to do things and develop our sort of repertoire of options when we interact with the world. So I think actually one really interesting way of thinking about the future of science is that why don't we build a theoretical science that just explores what's there? That would require doing something really cool, like saying, okay, we're going to build massive sensor networks, and you can build however many sensor networks you want, and they can measure any number of physical or biological qualities. And we're just going to download those enormous data sets, and we're going to let the AI find patterns in it. And when it finds patterns that are useful, it doesn't have to have a theory, patterns that are useful to accomplish something, then it's going to document them, and we're going to turn them into machines. But at that point, something interesting happens. At that point, we sort of lose visibility into science. It becomes opaque. It becomes very hard to explain. And so the question here, at some point, we could be in a situation where we have to choose scientific progress or scientific understanding.